So today, we're going to be talking about an exploration into a newly discovered supermassive superstar cluster. Recently discovered, there's a paper published about it, a new astronomical paper regarding the observations, and it's a pretty interesting case. In the Sky Report, we're going to be talking about planets and stars. There's going to be a lot of planets and stars this week after Thanksgiving and the Great Turkey Nebula that occurred last week. But yeah, it's a very, very stark contrast from this week to last week in terms of what's going to be in the night sky. And finally, we're going to be talking about the confirmation of a comet from a mysterious object that was observed back in 2021. So yeah. Anyways, we're going to be talking about that and more. This is Interstellar Insights. Alrighty, guys. So to start us off, we're going to be talking about this new supermassive galactic cluster that was recently observed. So start off, there was this astronomical paper. I believe it was published sometime within the last week regarding the discovery of Westerlund 1. I believe that's how you pronounce it, Westerlund. It's like a weird German name. But yeah, anyways, as I said, it's a supermassive galactic cluster. Now that's different from star clusters. The best way to put this is supermassive galactic clusters are types of star clusters. Main difference is that galactic clusters, in terms of like the amount of stars that are within the clusters, actually more loose. It's more loosely bound together compared to your typical star cluster. And you know, if we were to treat it like if we were to treat this kind of like a box, it'd be a very actually, no, let me rephrase this. You know, if it was like a box of air or something like that with all the air particles and stuff, it'd be very low dense because they're just all spread out. But they are loosely bound together compared to a star cluster, which is kind of medium bound. I mean, of course, if they're bound too much, you know, the stars would all be colliding, and you know, there'd be some super super giant star level celestial object kind of emerging out of that. But anyways, that's the difference. It's just more loosely bound together. But anyways, some kind of notes of observation that they discovered from this is that Westerlund 1 is approximately 13.8 actually not 13 13.8 thousand. I don't know what's with the wording with each day. It's been a long day for me. 13.8 thousand light years away. And then of course, while I use the term supermassive galactic cluster, the proper term is supermassive superstar cluster. So those refer to the same celestial beings. Common acronym is just SSC. And the amount of solar masses that they're approximating in Westerlund 1 is between 50,000 to about 100,000 total solar masses, aka stars. About, if every star had the same mass as the sun, that's like basically how many suns are in the super massive superstar cluster. But besides that, they also managed to estimate the age of Westerlund 1, which is approximately 5 to 10 million years old. So it's actually, in terms of the universe, it's actually pretty young, within its 13.7 billion year old life course. That's actually pretty young. I don't know why I stuttered there. But also, while observing across the night sky, they observed that Westerlund 1 in the night sky spanned about 3.26 light years across on its radius. And then besides kind of the general statistics, which I kind of laid out, they also discovered a lot of kind of structural things, if you will, regarding Westerlund 1. So mainly in terms of the structure, the stars, and like the shells and stuff like that, they discovered that there was basically an elongated kind of trunk, like kind of this part of Westerlund 1 that was just kind of protruding out, and it was estimated to be roughly span about 3.3 light years out from Westerlund 1. And then besides that, there's also structuring going on among the stars, mainly as there are like kind of mini clusters in Westerlund 1 that form around M-type supergiant stars within Westerlund 1, which is pretty interesting structurally, if you know what I mean when discussing some things. So yeah, and then right now, as we're speaking, there's still more observations done. They're trying to kind of they're working on the structure. That's kind of the big focus for this team, this international team that published this astronomical paper. They're trying to work out the structuring. They're trying to basically, if you will, kind of list out every star that's within Westerlund 1, from like every brown dwarf to every supergiant. They're trying to leave every stone unturned in terms of exploring stars. So yeah, that's what I've got regarding the exploration of this very massive super galactic star cluster, if you will, in our night sky. So anyways, with that being said, let's go over to this week's Sky Report. Alrighty guys, let's get straight to it with this week's Sky Report. So, reminder, this is probably the first time since like ever I actually remember to say this. All times listed, unless I explicitly give a time zone or say local time, which really applies to everyone in their local time zone. Just assume all times are in Eastern Standard, because that's where I live, so it makes things easy for me. If you don't live on the East Coast, go deal with it. Typical lecture about dealing with living in a different time zone, but yeah, you guys know what I mean. Anyways, of course, we got today, Wednesday, and then Thursday, Friday, 4th, 5th, and 6th. Starting off with tonight, Wednesday night, the moon is going to pass 2 degrees south Venus at about 6 p.m. and the two objects, the moon and Venus as a pair, are going to kind of creep up in the night skies. They're going to be about 16 degrees up in the evening night sky within the horizon. Anyways, besides that, if you plan on observing the moon and Venus, mainly and particularly for Venus, Venus is going to be at a magnitude of -4.2 in brightness, and it is going to be spanning as a disk about 18 degrees across in the night sky. So it's going to be a sizable object. Should be very noticeable as you look at it in the night sky. Anyways, tomorrow, Thursday, December 5th, my chair bumped back. Mercury is going to reach inferior junction at about 9 p.m. Although it won't be in inferior. Actually, it's not inferior junction. Inferior conjunction. That's a proper term. Inferior conjunction. It's going to reappear in the morning sky at least by the middle of the month, and then I can't remember off the top of my head, but I believe inferior conjunction is when the Earth is I think it's when the moon. It's either when the sun or the moon lines up with another object. In this case, it's going to be with Mercury, which means that you won't be able to see it in the night sky. So, I guess that's notable. But anyways, that's at night. I don't know why I started there, because there is stuff that morning, mainly regarding Mars, which is going to be pretty visible, and then in the high horizon, it's going to stand very high at around 3:30 in the morning local time, and then Mars is going to be in the constellation Cancer the Crab, where it's going to be the brightest object in that constellation. It's going to be at a magnitude of -0.6, and it's going to be sitting from another star cluster, not Westerlund 1, but M44, otherwise known as the Beehive Cluster, which will be shining at a magnitude of 3.7, and it's going to span 3.7 arc minutes across the early morning horizon. I'm talking about M44, not Mars anymore. But speaking of Mars, Mars itself will be spanning about 12 arc minutes across. It's actually, I don't know. No, it's. I'm talking about the disk of Mars. When you look at it, sorry. And then besides that, many features on Mars, mainly geographical features such as Valles Marineris and Solis Lacus are going to be the kind of most prominent geographical features that are going to be visible from Earth when you take a look at it this Thursday. But anyways, that's Thursday. That's actually quite a long time. But I don't think it's going to be as jam-packed as Friday, because Friday night we're going to be starting off by looking at Venus, which will be 25 degrees high at a sunset as in the night sky the planet is moving away from the constellation Sagittarius and eastward towards Capricornus in the night sky, which will be very visible. But if you are interested in stars and more constellations, there's actually going to be a ton of celestial objects that are going to be I mean, some of them are going to be in the actual constellation Capricornus, but other than that, I think that there's asteroids. So if you start off from Venus and you look east, you're going to find the star Auriga in the east, and it's going to be rising above another star, shining at a magnitude 0.1 Capella, which is the brightest star in Capricornus. So that should be very bright, very easy to find. And then just a little bit below, about 12 degrees below Capella, is going to be asteroid 15 Eunomia. I don't know why it's asteroid 15 Eunomia. It should just be in Eunomia, which is weird. But it'll hang out there. And then Eunomia itself is going to pass, I believe it's a star cluster, NGC 1931 at about 10 p.m. local time. That sounds about right. And then anyways, Eunomia is also going to be about 0.8 degrees due east of a magnitude 5.15 Aurigae. No, it's Aurigae. Yeah, Aurigae. And then it's also another object of note is to the southeast of Eunomia, which is going to be open cluster M36, open star cluster M36 there. So yeah, that sounds quite a mouthful. My throat. Well, actually, it's not true, but it's been tough for me to say all that. Excuse me, a little yawn there. Tonight, sunset's going to occur at 4:34 p.m., fairly early. Moonrise is going to occur at 10:27 a.m. Well, actually, that happened earlier. I don't know why it's on here. And moonset's going to occur at 7:31 p.m. Sunrise tomorrow, the 5th, is going to occur at 7:07 a.m. Sunset's going to occur at 4:34 p.m. Moonrise is going to occur at 11:05 a.m. And moonset is going to occur at 8:48 p.m. And finally, rounding off this 3-day forecast in terms of stars and dates and things like that. Friday, sunrise is going to occur at 7:08 a.m. Sunset on Friday is going to occur at 4:34 p.m. Moonrise is going to occur at 11:37 a.m. and moonset's going to end off at 10 p.m. And the phase of the week regarding these objects is going to be waxing crescent. That is the moon phase that these objects will be. It's the moon. It's the phase of the moon. I don't know why I said objects. I'm kind of losing my train of thought because there's just so much like this deep content that we have to talk about for the Sky Report. So yeah, that's the Sky Report. Very, very eventful week. Let's go move on to the second big topic that we're going to talk about. Alrighty, guys. So our second big topic, although I don't know if it's really a big topic, this is going to be kind of a shorter main session, but it's going to be about the confirmation of an asteroid belt object as a comet. Not comma. Did I say comma? I meant comet, of course. This is not a grammar podcast. That'd be really boring and everyone would fall asleep and everyone would leave basically instantly. But anyways, to provide some backstory, there was this mysterious object that was discovered in 2021 by a group of astronomers. Its location was in the main asteroid belt, so the asteroid belt between... actually, why did I make it sound like it's not a comet? Of course, we know the asteroid belt is located between Mars and Jupiter there. And, this object was still unidentified. They couldn't really classify it. But they gave it a name, and its name is 456P/Pan stars. You know how I feel about this, naming. It's really annoying. It really bugs me. Like, I don't know what these astronomers, think they're doing. They're just naming random stuff. No correlation. Like, Pan stars, like, there's 2 R's in that star. Like, I don't know what it stands for. Information I give didn't tell me what it stands for. So they need to, get it together. But anyways, that's my yap session about this horrible naming. But anyways, recently, I believe it was within the last week in 2024, they were able to observe it, and they confirmed that it's actually a Main-Belt Comet. So that's all. That's basically the end. But I want to talk kind of a little bit more about the science regarding what exactly a Main-Belt Comet is and how it has to be differentiated. Main-Belt comets are icy bodies that are found between Mars and Jupiter, of course, in the asteroid belt. It's if you know astronomy, it's considered rare. Because majority of the icy bodies, and this is where the majority of comets come from, actually come from the Kuiper Belt. Of course, that is where all the icy bodies are. That's where a lot of dwarf planets are. Pluto's in the Kuiper Belt, so... excuse me. Sorry about that. Yawns. Icy bodies are usually found over there in that part of the solar system, but then occasionally some objects kind of stray away and they get pulled into the orbit of Neptune. Does that actually happen? Is there a 9th planet out there that we haven't discovered? That was like the first episode we talked about, but that's not relevant here. We're talking about comets. But anyways, as I kind of got a little off track myself there, Main-Belt comets weirdly are classified as asteroids, and even though they possess many of the very similar characteristics, like a tail where a bunch of dust and ice is melting, and you get that little stream that goes across the night sky, they're classified as active asteroids, Main-Belt comets, and that's mainly because the orbit of Main-Belt comets is actually very similar to that, of asteroids. They share very similar patterns as opposed to comets, which kind of get close to the sun, and then the sun's gravity kind of shoots it off into another random direction, further and further away from it as it burns up. For comets, they get pulled in supposedly by Neptune's gravitational field, but there are some theories about that, but that's not the point. As soon as they enter, of course, they start melting. They develop a coma in the tail, typical comet characteristics, until they get really close to the sun, where I believe the gravity of the sun and some of the inner planets interferes with it, and it sends it shooting off in the opposite direction. So that's my I guess it's not mine. It's the second segment. That's all I've got for this segment. Yeah, pretty short compared to some of the others. But anyways, let's not let that stop us from getting to this week's edition of Astronomy Trivia, which we shall get to now. Alrighty, guys. Welcome to this week's edition of Astronomy Trivia. Before, of course, standard procedure, before I get into what this week's question is, I just want to talk about last week's question, which I believe was who discovered that the universe was expanding, I believe, was the right question choice. And the answer to that is actually going to be Hubble. I know there's a bunch of smart people. I didn't put Einstein on there, but Einstein actually disagreed, and within his, I believe it was within his theory of relativity, they put in the cosmological constant, which is kind of like mainly in the science world that caused a lot of disagreement, and some people in the science field kind of view that as like Einstein's lowest moment in terms of his career in science, but it was kind of a turning point because Hubble found evidence that proved the cosmological constant wrong, and in 1929 he proposed Hubble's law, which basically in layman's terms says that the universe is expanding. I believe he was discovering that there's a little bit of acceleration to that process, that the universe is expanding. But yeah, he basically debunked Einstein's theory that the universe is not expanding, and instead there's this cosmological constant that just kind of counteracts all these unexplained forces that cannot be explained by universe expansion. But anyways, for this week's astronomy trivia, your question is going to be, what planet in the solar system has the most moons? I want to say that again. What planet in the solar system has the most moons? I'm going to let you guys think about that. There's going to be a poll on YouTube and Spotify for respective viewers of each platform. I mean, you can send... I don't care. You can go and apply to the one on Spotify and, of course, to the one on YouTube. Well, anyways, that about wraps up this week's edition of Astronomy Trivia. Let's go close out this podcast. Alrighty, guys. So that just about wraps up this week's edition of Interstellar Insights. Next week shall be regular song and dance. Nothing out of the ordinary, if you will. Nothing, that affects scheduling. Although, in terms of in the long run, I'm still looking to find people, mainly close friends and such. Very, very interesting. And then, they have interesting stories to tell and such. To come on to the bonus show so we can get some more bonus show content, for at December. And then also, like I said, I'm investigating in the shorts, seeing if there's a way for me balance my schedule, or maybe I'll get a crew of some of my friends who want to kind of contribute and pitch out and help me make these or not make the podcast, but make educational shorts regarding astronomy. But yeah, that's basically everything I want to say. If you enjoyed this episode, smash that like button, and if you want to further support me, it really does mean a lot to subscribe or follow me, whichever platform you're listening to, because that'll help us grow our platform. Increase the quality of the show. Really, is the benefit. There's no downside to not subscribing. It's just a simple button to click, and you're done. But anyways, that's pretty much all I want to say. And anyways, this is Michael signing off.